Hey everyone, this is 507 week 6. I'm just going to go over a quick overview of data analysis, and then I'm going to talk a lot about your writing lab and what you should be finishing up for this week and thinking about the weeks coming up. The third point for our agenda for week 6 again is to make sure that you've scheduled a meeting with me, but also that this week at the very latest that you what is today? Today is Tuesday. So by Friday, make sure you have had at least a meeting with me and or met with your chair as well to make sure that you're headed in the right direction for your proposal. So make sure to sign up for those meetings. So again, week 6 quick agenda. I'm just going to go over a quick review of data analysis. You should have the basics from PH 504, and then I'll talk about our writing lab, and then again, just make sure you are meeting with me so we can talk about your proposal and that you've also scheduled time with your chair. Okay, so chapter 14, which is the chapter that's assigned, review that chapter for understanding and kind of jogging your memory again when it comes to biostatistics. But I'm adding these supplemental slides, and this is pretty much how what I want you to know for the final exam as far as the basic data analysis concepts. These are also concepts that you should consider for your analyses in your proposal. So again, they're pretty basic. So if you need to go back to your biostatistics course and review and look at chapter 14, please feel free to do that to help supplement. But these are the slides that I would say should give at least the fundamental concepts that you need specifically for this course, but just again, just kind of the basics of biostatistics and data analysis. Okay, the first part is a variable. What is a variable? It's kind of funny when you think about, well, a variable is simple. It's you know, a characteristic or attribute, something that is measured. But one thing I always want you to think about, especially as you're writing your research questions, is that a variable varies. So something, and students get caught up in this quite a bit. So if you think of a variable in that way, a variable is something that varies. That'll help you when you're thinking about what I'm going to talk about next. You know, what is your independent or dependent variable? The reason I say that is because sometimes people will say, I'm interested in understanding, let's say, how, this is a common one, how nutrition impacts Latino youth. And then when we ask, okay, so what is, you know, your variable? Sometimes people will list Latino youth as one of their variables. But if everyone in your study or in your sample is Latino youth, then there's actually no variation. If there were, you know, a variety of race ethnic groups in your study, then there's variation. So just really think about that, because I've already seen a few where people were labeling variables that really just were more your sample characteristics. They weren't actually a variable because that was just your sample or just a characteristic you were looking at. So for example, if you wanted to study how, let me think, sorry, it's coming off the top of my head. If you wanted to study how journaling and stress management impacted people who were living with depression, depression wouldn't be one of your variables because that is a part of your study. Everybody is living with depression, but what you're really interested in is journaling and how that impacts time management, for example. But anyhow, I just want you to look back at your research questions, and as you name your independent and dependent variables, make sure they actually vary. There's something different. It's either yes or no, it exists, or a scale 1 to 10, low, high. So again, that is a variable. And it seems pretty straightforward and simple, but sometimes you just have to think a variable varies. And okay, so the types of variables I kind of alluded to. So you have either your independent or your dependent variable. Sometimes when people talk about their independent variable, it can be the predictor variable, or it's often denoted with an X. So it's really the thing or that exerts some influence, or the thing that you're anticipating that exerts influence. So some independent variables could be gender, race, age, intervention. So does an intervention influence some outcome? It could be other outcomes too, like does stress level influence how you take an exam? So it's really the thing that is exerting influence. And then the outcome, or dependent variable, often denoted with a Y, is the variable that is being studied. I kind of sometimes in the past when I was studying would get these mixed up, but just think about like a dependent variable depends on something else. So how I do on my exam depends on stress. So if I was looking at stress level and its impact on exams, then a stress level is the independent variable, its impact on the dependent variable, which is how you do on the exam. But again, dependent variables can be attitudes, beliefs, knowledge. It could be specific behaviors. It could be disease outcomes. But just know that not all variables are exclusively going to be either an independent variable or dependent. I mean, some things you can't change, race, age, for example, and gender. So it's not that something could influence those things, but in general, you can have, variables. Maybe you're looking at stress as an outcome. So what influences stress? So now that becomes your dependent variable. So just know that variables are not exclusive. Most variables are not exclusive to independent or dependent. What you have to do to determine that, again, is just think about the research question and what you're asking. What do you think is influencing or impacting the other thing? So that's your independent is either impacting or influencing your outcome variable or your dependent variable. So that's one way to kind of think about it. So here's another way, and this comes from, to kind of think about these things, this comes from a theory lecture. I think you've had it in another class or maybe in this class as well. But if you remember a theory of a reasoned action, the concepts are either attitudes, norms. I think this was an HIV intervention model. But when you actually turn it into your own construct or your own model, then you start to look at different types of relationships. So one variable, for example, could be on a scale of 1 to 10, with 1 being least important, 10 being most important. How important is wearing a condom to your friends? So that is probably asking about peer norms. So again, there's some variation there. But what I want to show you is that, if you're looking at this HIV intervention model, and let's say you had a very short study, you might say, I'm really interested in understanding peer norms and attitude and how that influences intention to use a condom. So attitude and peer norms are your independent variables, because you're wondering how that impacts intention to use a condom. But let's look at another relationship. Let's say you have a little bit longer time to do your study, and you have more money, oftentimes. So you're really interested in understanding whether someone's intention influences their actual behavior. So now intention to use a condom becomes the independent variable, and you want to know whether that influences condom use. So this is just one way to illustrate, and you're looking at this model, that intention to use a condom could either be the thing that you're studying, could be your dependent variable, or it could be what you're wanting to understand whether intention impacts actual behavior. So again, variables can either be independent or dependent. It really just depends on the questions you're asking and, of course, the types of variables that you're looking at. Okay, so thinking about data analysis, you can have descriptive, statistics. It could be means, ranges, percentages, or inferential. So there you're trying to figure out some type of a relationship, maybe causality. You're using a sample and trying to make some type of generalization. There are 3 types of statistical analyses. So one is univariate, so one variable is involved. bivariate, 2 variables, or multivariate. So there's more than 2 variables that are in the analysis that you're trying to understand. So here's some example questions. So in a univariate analysis example, you might ask, what is the average score on a cholesterol knowledge test? Or what is the average of XYZ? So you're really just asking one thing, and it would be the average is whatever it is. Or you might be asking how many participants, at the worksite attended a healthy lifestyle presentation. 10 attended. So again, it's just one variable. When you move on to bivariate analysis, now you want to know the relationship between 2 variables. So for example, we'll just look at the first one. Is there a difference in smoking behavior between the individuals in the experimental and control groups after the healthy lifestyle program? So is there a difference in smoking behavior essentially between the experimental group and the control group? So smoking behavior is one variable, and whether or not someone is in the experimental or control group is another variable. Because always remember, intervention itself is a variable, whether someone's in the intervention or not in the intervention. So again, that first one, the 2 variables are smoking behavior and whether or not someone is in the experimental or a control group. And then multivariate analysis, now you're just interested in, can the risk of heart disease be predicted by using smoking, exercise, diet, and hereditary. So smoking, exercise, diet, heredity are all of those variables related to heart disease. So again, it's just more than 2 variables. And then you could look at the other examples to kind of read. So again, univariate, just looking at one thing. Bivariate, there's 2 variables involved. And multivariate, there's more than 2 variables involved. So again, univariate, so you might be looking at counts, so the number of, you might be looking at means, median, mode, spread, like a range, variance, so you're really just trying to determine whether scores from groups are similar and how they're spread apart. And it is useful, especially if there's extremes, you can kind of see where there might be some outliers. So again, it just has to relate to one variable. And then bivariate analyses. So it's common to think about differences in the form of a hypothesis. So is there a difference or is there no difference? But there are 2 types of hypotheses. One is a null hypothesis, and the null is that there's no observed difference. So when you have a hypothesis that says my hypothesis is that there is no difference between the intervention and control group, that is a null hypothesis. An alternative hypothesis is that there is a difference. So the alternative hypothesis might read, my hypothesis is that there is a difference between the intervention and control group when it comes to stress level or whatever variable you are studying. So again, null means no difference. So you can just think N for no. So null means no difference. And then the alternative is that, well, yes, there is a difference. And then, of course, we're always looking at statistical significance. So is there significance here? So that really refers to the observed difference between 2 or more groups and whether there is a chance occurrence. And I'll talk a little bit about how we look at statistical significance and at what level we set the significance at. So in thinking about the bivariate analyses and different types of hypotheses, kind of thinking about the null hypothesis, there are 2 types of errors. So type 1 error is that you are rejecting the null hypothesis when the null hypothesis is actually true. So it's kind of a false positive. So you reject the null, which means you're saying there's no difference, kind of double negative, when it actually is true. So again, it's kind of a false positive. And then type 2 errors, like a false negative, is that you fail to reject the null. So you're saying there is no difference when actually there is. So it kind of gets confusing when there's so many double negatives, double positives. So how do we look at this kind of in this chart? This is a really good one to memorize, and even just being able to write it out yourself, because sometimes it's like, wait, the null, the alternative, or the false, or reject. But if you can just write it out very simply yourself, then you can kind of fill in the blanks and it'll help jog your memory. Very simply, what I would do for the rows is actually put reject null and do not reject null. When you reject the null hypothesis, you're really saying that you're rejecting that there's no difference, meaning, yes, there is a difference. When you do not reject the null hypothesis, or you fail to reject, you do not reject the fact that there's no difference, meaning, yes, there's no difference. It's kind of confusing. And then when you look down the columns, it would be either the null is true, so this is reality, and the null is false. So oftentimes, well, the reason we're doing statistics is we don't know reality, so we're doing the best to predict and understand and do our statistics. But if we knew reality, and sometimes we do, but not really, this is the table that you kind of want to think about. So when the null is true, it means that there's no difference, because null means no difference. And when the null is false, that means there is a difference. So if you kind of look at this table and where it's discrepant, so when you reject the null, even though it's true, that is your type 1 error. And again, that's a false positive. And on the flip side of it, when you do not reject the null, but it is in fact false, that's a false negative. And then of course, if you reject the null and the null is in fact false, that's your true positive. And if you don't reject the null, and in fact the null is true, that's your true negative. So I know it gets a little bit confusing, but if you're able to write this table out yourself with reject null, do not reject null, and then the kind of reality, the null is true or the null is false, then you can kind of work this table out, understanding, you know, what is a type 1 error, you know, it's a false positive, and what is a type 2 error, which is a false negative. And oftentimes we set our significance level at, or our error, type 1 error, at 0.05. So what that really means is that there's a 5% chance that the finding was a false positive. So basically, we're 95% sure that it's a true positive, but there's a 5% chance that it was false. So 5% is a common level to set your level of significance. In different other either departments or areas of study, sometimes people might set it at 0.1 or 0.01, but generally 0.05, or as it's interpreted, 5%, is usually how we set the level of significance. Okay, so there are several types of bivariate analyses. And the one thing you want to make sure you know at the most basic level is what type of variable you have. Do you have categorical variable, black, white, red, which could be nominal, like black, white, red, or ordinal, that's categorical still. So less, more. I'm just kidding. So Likert scale type things, or is it numerical? You know, 1 through 100, and a continuous variable. So I'm kind of throwing out different terms there, but again, nominal and ordinal variables are categorical. And then when you're looking at something that's continuous, that's numerical. Okay, so let's go, so just make sure you understand what type of variable do you have. And sorry, one example could be if you're looking at stress level and you have a scale from 1 to 10, that's numerical because you have this continuous variable. But let's say you wanted to only look at high stress versus low stress. Well, now you've made it categorical and you've made it, I guess, somewhat ordinal. Maybe if you had low, medium, high, then you definitely have an ordinal type of variable. But again, it's categorical. Okay, so if you are looking at two categorical variables, So it's either nominal or ordinal, whichever type of categorical variable. And a classic one is looking at a 2 by 2. You're most likely looking at counts and percentages. So the analysis that you would do is a chi-square. I'm trying to think. Maybe you're looking at high stress versus low stress for men and women. So this is going to give you counts. It's going to give you percentages. If you can imagine a 2 by 2 table, one side is male, female, the rows and maybe the columns are stress level, high, low. So it's a 2 by 2 table. You're going to do chi-square. Let's stick with that example. So now let's say, what is a t-test? This involves both categorical and numerical data. So here you're studying the differences between groups when the dependent variable involves an interval or ratio data. This means that your groups could be, let's say, men and women, and then your outcome variable, your dependent variable, is numerical. So numerical could be, and your continuous variable could be an interval or ratio data. So you'll have to go back to notes or kind of Google those terms. But again, it's more about something being a continuous variable. So let's say you're looking at men and women, and you want to know stress level. Well, we're not going to do high and low because that's chi-square. But now we're going to use a scale, and the scale is 1 to 10. And so now I want to know from 100, 50 men, 50 women, what is the average stress rating that they have? And I'm going to look at the average for men and the average for women, and I'm looking at the average stress scale. So that would be a t-test because I have just two groups, and I'm looking at their average stress score. So if you have something similar to that where you have two groups and some type of interval or ratio data, again, it's numerical, then you have t-test. Now there's two types of t-test. There's one group twice, and that's dependent. So let's say you had 100 people and you wanted to measure their stress. I don't know why I'm focusing on stress. I'm actually not too stressed nowadays. But anyhow, let's say you have 100 people and you want to look at stress at time 1 and time 2. Well, now time becomes a variable. You have time 1 and time 2, and you have stress, which is on a scale. But time 1 and time 2 are the same people. You're just looking at them at different points in time. So how you link the two, they're actually dependent, because if I'm taking it in time 1 and time 2, I'm the same person. My scores are going to be correlated and related to each other in some way. Because again, it's the same person taking it at different times. So one group of people doing something twice, that is called a dependent t-test. But the one I was describing earlier is an independent t-test because we're looking at two groups once. So we're looking at men and women and their stress score. So that would be an independent t-test because the score of one person, one man is not the same for, has nothing to do with the scores for the women. You know what I mean? So again, that's independent. They're two totally different groups, but we're looking at their average stress score. And again, dependent would be if we're looking at stress score for the same group of people, but at time 1, and then let's say 6 weeks later at time 2. So it's the same group of people at two different times. So that's the difference between a dependent t-test and an independent t-test. Similar to a t-test, let's say instead of men and women, you're interested in looking across race, ethnicity. So you're still looking at numerical data. You're still using a stress score from 1 to 10, but you want to look at the difference between Black, white, Asian, Hispanic, etc. So now you have more than two groups. That's going to be an ANOVA. So more than two groups, but you're still looking at some kind of mean or some kind of score. Again, it's numerical. That is ANOVA. And if you have two numerical variables, so let's say now we're going to throw in age. So age can be 0 to 100, and stress could be 1 to 10. Both are numerical data. They're continuous variables. So you're going to have, that is when you look at correlation. And correlation only looks at relationships. It in no means looks at cause and effect. The only way, and we've talked about this in other lectures, you can really do cause and effect is if you're doing like a randomized control trial and you have this intervention, then maybe you could do cause and effect. But again, when you're looking at these type of studies, you know, one shot in time, oftentimes you're just looking at relationships and not cause and effect. But again, looking at correlation. So let's say the older you are, the more stressed you get. I'm just making this up. Maybe it could be true. I don't know. That would be a positive correlation because the more of something, the more of the other. The greater the age, the greater the stress. But let's say we are doing something around meditation. So the number of minutes of meditation, so the greater, the less stress. That would be a negative correlation because one is going up and while the other is going down. The greater number of minutes of meditation per week is correlated with less stress, so it's a negative relationship, a negative correlation. So that's just another visual way of thinking about correlations. And then we have multiple regression. So this is part of your multivariate analyses. So this is when you're not just looking at one or two variables and their relationship. Now you're looking at how do these three things affect, what was the other example? Heart disease. There's different types. Multiple regression is the most common. And the equation you see there is kind of the most basic equation. And one way of looking at it is, let's say your Y or your dependent variable is BMI, and you're interested in understanding whether eating, exercise, and, oh, I can't see the other variable. It's behind my picture. Let's say stress, for example. Are those three things, how do they impact your dependent variable? How do they impact BMI? So that would be a classical way of writing out multiple regression. So if you have this type of equation, you're interested in three factors, which are denoted by X. Again, these are your predictor or independent variables. How do these impact BMI? This is how you would write out a multiple regression equation. But let's say we're just interested, for simplicity, in either good BMI or bad BMI. We don't look at it that way, but just for simplicity. Now we're interested in whether eating, exercise, and or stress, I forget what the third variable is, eating, exercise, and a third variable, are those related to good BMI or bad BMI? That would be called logistic regression. So there are many types of regression, but logistic is if the Y is dichotomous. Dichotomous meaning yes, no, it's there, it's not there. So it's just good, bad. It's just split into two. So again, BMI is normally a continuous variable, and this is how you would write out multiple regression equation. And you would write it out the same way, but if that outcome variable, the dependent variable, if it is split, so it's dichotomous, then you would conduct a logistic regression. So that is multiple regression, and just an example way of writing it out in case you are using it for one of your research questions. Okay, so let's look at two examples of application. So this one says, for their program goal, it's to reduce the prevalence of smoking in the priority population. The priority population is 140 employees of company X who smoke. The intervention, which is the independent variable, is two different smoking cessation programs. And the variable of interest, which is the dependent variable, is smoking cessation after 6 months. So basically there are two types of programs, and they want to know what is the smoking cessation percentage after 6 months. And if you remember all the X's and O's related to intervention design, this is a randomized design because you see the R's. This is a randomized experimental design, and it has post-test only. they're really just looking at how does the intervention influence their one outcome, which is smoking cessation. So that's why they have X1 and X2 and observation 1. And the kind of X1, X2 is like method 1, method 2 are the different types of interventions. So if you look at the way the data is collected, it's nominal data, so it's either they quit, yes, or no. So again, the dependent variable is smoking cessation, and the way they collected it was by asking, did you quit, yes or no? So now you have basically two groups. One group that got the first type of intervention, and then the group that got the second type. And they either quit or they did not quit. So you have a classic 2x2 table where you can fill in actual numbers. If there was 100 people here, you could see, or 200 people, you could see exactly the percentages. So again, this is a classic 2x2 table, and again, because it's two categorical variables, we're going to do a chi-square test. Here's another example. So here the program goal is to increase knowledge of HIV/AIDS within the priority population, which is 3,200 incoming freshmen at University X. The intervention, again, which is the independent variable, is a 2-hour lecture presented during the freshman orientation. The variable of interest, which is their dependent variable, is knowledge of HIV/AIDS. And the program design is, if you remember again from your X's and O's, is a non-experimental pre-test, post-test only. So again, pre-test, post-test, and the intervention is a 2-hour program. The way that they collected the test scores was that it was on a 100-point scale. So now, again, if you think about it, there are two categories. So you have two categories. It's a categorical data, whether it's before and after, or pre-test or post-test. But then you're looking at the same group of students before and after, and their average score. So for example, both have 3,200 students. At pre-test, their mean score for HIV knowledge was 69, let's say 69%. And then at post-test, so after they received an intervention, now it's up to 78.5. Now, if you remember the difference between dependent and independent, this is kind of like a time 1, time 2, pre-test, post-test, but it's the same students taking the test before and after. So how you score the second time really depends on you as the person. It is related to your first score. So that's why it's a dependent t-test. So in general, it's a t-test because you have two categories and you're looking at the mean of something. So in this case, the category is test result, pre-test, post-test, and then you're looking at the mean score for their HIV knowledge. If you were just looking at group A, group B, it would be independent because it would be two different people that maybe, two different groups of people that maybe received two different types of program. But in this case, it's the same set of students who took a pre-test, received an intervention, and took a post-test. So now you're looking at dependent, to do a dependent t-test. So those are two examples that hopefully help conceptualize when you would do chi-square, when you would do a t-test. If we were to take this further, and let's say we were looking at mean scores, but we're adding a third group, then remember 2 or more groups, similar to a t-test, but now we're getting into ANOVA. So hopefully just looking at these two applications of data analyses can kind of help you think about, 1, what type of data you have, and then 2, what does that mean as far as the type of statistic that you would run. And of course, when you're interpreting your data, there's different ways that you can interpret it. But the first one is, did you achieve your objectives? Did you not prove, but did you, answer your hypotheses? It can help determine the value of accomplishments. You can compare results. with some other study or maybe a larger national survey. So the CDC found in 2019, this percentage of people had XYZ, and my study was consistent, so you can compare results. But you always also want to interpret the results in light of the evaluation procedure. So what type of a study was it? What was the quality? So just be really mindful about how you interpret your data. You're not saying something caused something when you're not doing the right study design. You're really not using too many absolutes. But also, just in general, think about what is the value of the accomplishment. So what is the implication of your findings? Okay, so for the writing lab, what I want you to do for this week is to make sure that you are meeting with your chair and your other committee person to go over your proposal slides, just to make sure your research questions are solid, your methods are pretty much on track, so that you're ready to give your quick proposal presentation. Now, don't forget about the paper. There was I think a couple students who were like, wait, there's still a paper? That's the main part. So I think I have been talking about the proposal presentation a lot, but just remember your presentation is based off of your paper, which is 5 to 7 pages, where you really go into depth outlining your introduction, your methods, what statistics you're going to use, etc. So if you remember, we've kind of created this portfolio where you have your paper and you have a reflection and competency. So that's actually Writing Lab sort of item number 2. I want you to review, just so it's doesn't come up as a surprise at the end, or you try to tackle everything at the end. Review the portfolio. Along with the paper, you're also going to fill out a competency form, and that basically just says, think about 3, public health competencies that you are fulfilling by doing the project that you are proposing, whether it's a thesis, a lit review, secondary data analysis, primary data collection and analysis. What is it about the different types of public health competencies that you are achieving? And then you also want to start thinking about, why is that in your 1 to 2 page reflection paper. So it's really just meant to make sure that your thesis or capstone is aligning with some of the most fundamental public health competencies, and that you can reflect on that as well. So within Google Course, in this week, and I'll also include it in week 7 and 8, there is a portfolio guide folder. And that's where you're going to have all the details about what goes into your portfolio. And again, it's the paper, it's a competency form, it's a reflection, and so there's a guide and a couple of sets of things to look at related to the portfolio. So make sure you look in that folder for more details. It's originally due October 13th, which is still just about 2 weeks away. So I think you have plenty of time. But I will extend it to Wednesday. I don't want to extend it too much because I want to make sure there's time in between when you're submitting your portfolio and the days after where you can study for your final exam. I don't want to put them at the same time because one will end up being sacrificed. And I want to make sure that I'm setting you up for success so you can finish your portfolio and then at least have a few days to study for your final exam. So again, even though I had it originally due for Sunday, October 13th, I will extend it to October 16th. So you still have over 2 weeks to put your portfolio together, but I just wanted to give you a heads up and make it a part of this week's writing lab. So again, make sure you're meeting with me, with your chair, the people on your committee, so that you're kind of reviewing your research questions, your methods, even your statistics, basically reviewing your proposal presentation, which again should be based on your paper, and that you're just really starting to dig into what do I need to do for my portfolio and to get that together. So again, make sure you're spending a couple of hours this week in your writing lab. And then as always, let me know if you have any other questions. Talk to you soon.